Hello, I'm Professor Todd Huffman at Oxford University, and I'm going to answer the age-old question in the Atlas detector: how do we know that anything at all has happened? Behind me is a Minecraft image of the Atlas detector. So the first thing that happens is we have protons in the big LHC accelerator, and we have protons circulating around them and then colliding. And the collision happens in the center of the Atlas detector. But then, once that happens, how do we know that anything has happened at all? So when the protons collide, they hit each other, and many particles come flying out. As the particles come flying out from the collision, the first thing that we encounter is called the pixel detector. And it's called a pixel detector because that's exactly what it's made up of. The same sort of picture elements, or pixels, that are in the mobile phone that I'm using to record this. They are identical. The detectors that we have, they detect the charged particle that passes through the sensor in exactly the same way. So when the charged particle passes through the silicon detector, and it shows up as a hit. We then layer the detectors one after the other. So as a charged particle flies through, each individual pixel is hit, and as the pixels are hit, then you can later on determine that this is where the particle went. Now, one particle is not a big deal, but when we start seeing hundreds of them, then we know something definitely has happened. But we're not done, okay? Because each pixel, of course, we know where it is. We built the detector, so we know where they are very precisely. And by precisely knowing where those hits are, we can reconstruct this track. We're still not done. Because just because the particles pass through, we can make more measurements by using the fact that many of these particles aren't themselves fundamental, even though they're smaller than atoms. They are made up of smaller particles like the proton called quarks. And those quarks interact very strongly with each other. And so what we do once we have the track is we put very dense material, in our case lead or steel, afterwards. And then the particle will strike the atoms of actually not just the atoms, but the nuclei themselves of lead or steel. And that will break those nuclei apart, producing even more charged particles, which can strike other nuclei and break them apart. It's called a shower. And so we'll get a shower of charged particles after the tracker at further radius and measure all the charge that comes out of those charged particles. Again, this occurs with hundreds of particles coming from the center, and so it's really clear that something has definitely happened.